Hi everyone, it is Miss Osborne's homework helper, and today is the 5th of December. For this week's homework, I sent home one reading page, and it was about our science content, working with animals and their basic needs, or organisms and their basic needs, really. And then I sent home a page that I believe was just about which of the organisms and non-organisms listed above are living, and then explain your thinking at the bottom. And then I also sent home a math connections page, so I'm going to be going over that first. So I am working on the math connections page that says A at the top. And I'm going to go ahead and work through this whole sheet first because this goes over a variety of skills. And I'm sorry, I don't know when it printed what this little weird sign is, so we're just going to ignore that. Okay, so the scenario. Ariel tracked the growth of a certain fungus growing on a tree. The fungus lives on the tree in order to absorb sugars and other nutrients for survival. In turn, the fungus helps the tree by absorbing water for the tree. Every day she recorded the area in centimeters squared of the tree that the fungus covered. She also recorded the volume of water it absorbed in milliliters. She recorded her results in the following table. As you can see, there's a table down below. It says amount of water absorbed and area of fungus grown at the top, and it has days across the top, and then down the left-hand side, it has area, fungus, and water absorbed. Just looking at this, I see that the trend of the numbers is increasing as the number of days increases. So that's just my first thought looking at the chart. So what is the pattern of the growing fungus? So when I'm looking at this, I'm looking to see what the pattern is. I notice that the days are going up. I notice the area of fungus is increasing, and I notice the water absorbed is also increasing. So you would need to look at and determine the pattern. I notice from the top that the area of fungus is increasing by between day 1 and day 2, it doubled. In the day 2 and 3, it doubled again. Day 3 and 4, it doubled. And day 5 and 6, it doubled again. So when I'm looking at this, I see that 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 8 is 16. 16 plus 16 is 32. So the area of fungus is doubling daily. Water absorbed. So day 1 is 1 and day 2 is 3. Day 3 is 8. Day 4 is 16. Day 5 is 32. Day 6 is 64. I know these numbers have some relationship. I don't think the days and the amount of water absorbed have a relationship, but I definitely notice a correlation between area of fungus and water absorbed. So 2 times 2 is 4. 4 times 4 is 8. 8 times 8 is 16. 8 times 8 is not 16. So it's doubling again. 2 times itself is 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 32. 16 times 2 is 32. 32 times 2 is 64. So that would be the pattern. I would say the pattern is doubling. So that's what I'm going to write. The pattern is doubling. Simple. I can write in a sentence just like that. What area will the fungus cover on day 7? So it is asking us to extend our graph, but we don't have that information, so we're going to have to make our information. When it asks us to extend our graph, I like to actually do that myself, so I went ahead and extended it just like this. I wrote day 7 right over here. So I know that the pattern going across the top is doubling. So 32 doubled is 64. So I know that on day 7, the trend would be 64 centimeters squared. Then I know that I was doubling between the area of fungus, and it doubled the amount of water absorbed. So 64 times 2, So let me go ahead and write that out, just to be careful so I don't make any mistakes. So 62 times 2. 2 times 2 is 4. 6 times 2 is 12. So 124 would be the answer there on the bottom, 124. So I want to write down below that 64 centimeters squared is the area of the fungus, and the water absorbed would be 124 milliliters squared. So my graph would look like this. Ooh, it's a little dark in here tonight, I'm sorry about that. Graph would look like that, and my answers would look like that. I'm sorry, my hand's causing a shadow. And I have my math over here to support it. Okay. I'm going through this whole thing because this is different math for us and it is a review. So if you think you're understanding how to do this, I encourage you to pause the video, try it yourself, and then come back and watch and see how you're doing. Try to push yourself, test your limits. Okay, number 3, how much water will the fungus absorb on the tree on day 10? Wow, it's really asking us to extend our knowledge here. That was day 7. So I'm gonna think, okay, I'm gonna extend it on my whiteboard since I don't have room on my paper. You might need a scratch piece of paper for this. So day 7, 8, 9, 10. Here's my days across the top. It's asking me to extend it. So I just made my own little graph like that. So we have the knowledge for day 7. So that was 64 and 124. So we know the bottom, the top number is the area of fungus, and the bottom number is the water absorbed in milliliters. So the trend, the pattern across the top is it's doubling each time. So I'm going to have to double 64 for day 8. So 64 doubled is 124 because it's doubling. So if I was to double 124, that means I multiply it by 2. I would say, okay, 4, so if I'm multiplying each one of these by 2, 2 times 4 is 8. Oops, sorry for my terrible 8. 2 times 2 is 4, and 2 times 1 is 2. So then if I have to double this number, 248, to get 10, to get day 10's amount of, or area of fungus across the top, I'm going to go ahead and, I should actually have a piece of scratch paper for the math, but I don't, so I'm going to use the back of this paper. So I had the number 248 for day 9. I need to double that. So 248 times 2. It's kind of how I set it up, that single number by multiple digit, or multi-digit by single number multiplication. So 8 times 2 is, sorry, that's really hard to see. Let me see how I can double that. 8 times 2 is 16. I carry my 1. 4 times 2 is 8, plus 1 more is 9. 2 times 2 is 4. So guys, it's a really, really important that you know your multiplication facts because it's going to make your life a lot easier. Okay, so I know that my last number here is 496. So if you've extended out to day 10, your chart should look like this so far. Area of fungus across the top, and at the bottom we're going to do water absorbed. Now, if you remember from above, the pattern for water absorbed is it's double the number, or double the amount of the area of fungus. So luckily I have some numbers here I can use. So 124 doubled is 248. because I've got that number right here. I've already done that math. So definitely think about the numbers you have. Don't exhaust yourself and do unnecessary work. So I know that 248 doubled is 496. Oops. 496. Sorry, I'm trying to write with my left hand here. So now I need to figure out what 496 doubled is. So I'm going to use my scratch paper again. 496 times 2. So again, the multi-digit by single-digit multiplication. Okay, so I'm going to start here with 2 times 6. 2 times 6 is 12. Carry my 1 up high. See, I carried my 1 up high. 9 times 2 is 18, plus 1 more is 19. So again, I carried my 1 up high. 2 times 4 is 8, plus 1 more is 9. So my answer would be 992 for amount of water absorbed. So there's all my numbers again. So really this should be review, but I like how it's in the context of what we're learning about in the basic needs of organisms. So now day 10, I'm going to answer the question. How much water will the fungus absorb for the tree on day 10? Well, I found out by my doubling process that 992 milliliters squared will be absorbed on day 10. It's right here. Okay. So now I'm working on number 4. If there were a violent storm on day 10 and only 1/4 of the fungus was left, what area would the fungus cover after the storm? Wow, okay, I don't know if you guys noticed this, but this little number right there, that's a fraction, and that's what we've been working with. So, if there were a violent storm on day 10 and only 1/4 of the fungus was left, remember that's that middle number area of fungus, what area would the fungus cover after the storm? So it sounds like to me we need to take this number, 496. I'm going to go ahead and erase on this. And 496 and we need to multiply it by 1/4. I'm gonna rewrite that number really quick. 496 times 1/4. And I'm doing that because I'm trying to figure out if the area was divided into 4 parts, how much is that one part, that 1 unit fraction that's left? How much area is that exactly? So I know that when we're multiplying whole numbers by fractions, I need to take the whole number multiplied by the top of the fraction. So 496 times 1 is 496. And my denominator comes right over. So now I've turned this into a division problem because it's an improper fraction. I'm having to make it into a mixed number or whole number, whatever the answer is. So I'm going to go ahead and write this as a division problem because I have to figure out how many times 4 goes into 496. So I'm going to write 4 into 496. Okay. This is a long division problem, so I'm going to walk you guys through it. 4 goes into 4, how many times? Just 1 time, with none left over. 4 goes into 9, how many times? 2. 2 times 4 is 8 though, so that means there's going to be something left over. Nine minus 8 is 1. Then I have this 6 left over here just hanging out. I need to drop this 6 down. Okay, 4 goes into 16. How many times? 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. So I bring that 4 up here. 4 times 4 is 16. So I don't have any leftovers. So our answer here is 124 square centimeters are left over after a storm on day 10. So let's go ahead and write that. 124 square centimeters are left over. And I'm going to even write my problem down here. 4 into 496. Just like that. Okay. Now I'm flipping over onto the back side. This is part B. We're switching and we're working with larger organisms now, not smaller. So for this one, I'm going to do the first problem with you, but a lot of this math is the same. It is the same as on the front. So I'm gonna leave that part to you guys to try to figure out. We'll talk more about that in a second. So I'm gonna read the scenario up at the top. Let me move this. Elephants are very important to the local ecosystem. Jack tracked the number of elephant births over the lifespan of an elephant community. He tagged each mother elephant with a number and recorded the number of calves, baby elephants, that each mother birthed over the course of her lifetime. His results are recorded in the following table. Use the table below to answer questions 5 through 10. I'm looking at the table that starts by saying observations in elephants. Number of mother elephants, 1, 2, 3, 4. So they had different elephants they were observing. Number of calves. Number 1 had 5 calves. Number 2 had 10. Number 3, 15. Number 4, 20. Oh, so this is the number of elephant births in the community. So he tagged each mother elephant with a number and recorded the number of calves. So each of these are individual elephants. Milk needed for calves, liters per day. Wow, this is a lot. 50, 100, 150, 200. So the first question is, on average, how many calves did the mother give birth to? Okay, so number 5, 10, 15, 20. So if there were 4 mother elephants, so number of mother elephants, this is saying there's 4 mothers, and there's 20 calves birthed. So 20 divided by 4 is 5. So I'm going to check my theory here because I'm not quite sure it's 5. That is the average number of calves each mother gave birth to. So 3, if there's 3 mother elephants, the number of calves was 15. 15 divided by 3 is 5. Okay, if there was 2 elephants, 2 mothers, and there were 10 calves, 10 divided by 2 is 5. And if there was 1 mother, there was 5 calves. So to me, that's telling me the average number, on average, how many calves did each mother give birth to? The average is 5 calves. So to continue your math work tonight, what you're going to do is you're going to determine the pattern for the number of calves. So you're going to be looking at this information here in this middle bar. Number 7, you're going to use the pattern and you're going to predict how many calves 5 mother elephants would have. So you really need to extend this graph. And then number 8, how many calves would 8 mother elephants have? You need to extend the graph a little further. You're definitely going to be needing some scratch paper. Number 9, using the pattern, you're going to predict. Predict is another word for an educated guess. You're going to take an educated guess. Predict the number of mother elephants needed for 55 calves. So if there was 55 calves, how many mothers would there be? Number 10, how many liters of milk per day would be needed to feed 60 calves? So down here, you're going to be looking at number of liters, and you're going to be looking at for 60 calves. I hope this helps. Please reach out to me if you need some assistance with this. I hope this math homework is a little more engaging than because it's in a scenario and stuff we're learning about in science. So it's more engaging for you to do, and it helps bring back some memories of 4th grade and 3rd grade math and practicing those multiplication tables. Okay, have a good night.